Fundamental theorem of calculus. Okay, now I see that there's an x right there. I don't know if that freaked you guys out, but you're going to take the antiderivative with respect to t. That's what this means right here. And then you're going to plug in the x or the function, whatever's up there. So here we go. This is what we're going to do. I'm going to rewrite this so that it says the integral from 0 to sine x of x raised to the 1/2 power. No, not x, dang it, t. T raised to the 1/2 power dt. So I'm going to do the antiderivative of the integrand, whatever's inside the integral there. And so in order to do that, I got to add 1 to the 1/2, which would be, or would be t to the 3/2. And then I have to divide by 3/2, but you start getting fast at this. If I divide by 3/2, that's the same as multiplying by the reciprocal. And what's the reciprocal of 3/2? 2/3. So I'm going to get 2t to the 3/2 divided by 3. All right, and then don't forget your lower and upper limits. This is one way you guys can write it so you don't forget it. And then you plug them in. You got to plug the top one in first and then the bottom one. So we got 2 times sine x, and that's raised to the 3/2, divided by 3. And then we're going to plug in 0, so we'll go minus, and we go 2 times 0 raised to the 3/2 divided by 3. Okay, now 3 raised to the 3rd power, and then the square root of it is just going to be 0, and 0 times 2 is 0. 0 divided by 3 is 0, so this part doesn't matter. I think I will write my final answer, though, with a 2/3 in front. Take the sign out of the fraction, and that's what you get. So y actually does equal this. All right, see, y equals the integral, but when I do the fundamental theorem of calculus, I get this.